Right. So looks like we are also live on YouTube. Just checking out if it is all streaming well. Vinayak, I think you can also acknowledge if you're able to see things on YouTube as well, so that we can get started.
Yeah, I'll just check. Yeah, we are live on YouTube.
Okay. Right. So hello, everyone. Good evening to all of you. Thanks a lot, everybody, for joining to today's session, which is a day 3 of electric vehicle uh, technology certification bootcamp. So good to have you all here. So it's always great to catch up with people who are interested to learn about EVs or interested to explore their career in the areas of EV. As a part of first 2 days, we have covered up overview details of EV technology. Second day, we have touched based on hand calculations for electric vehicle component sizing. On today's session, we will be covering up on EV testing, right? So this was a day module 3 of the module 3 and day 3 content as we have promised you in the bootcamp landing page. So today we have Mr. Srinidhi, who is our EV R&D engineer. Srinidhi has been involved in extensive testing activities of electric vehicles. We are also at Decibels developing our own electric bike. So he's been the person instrumental in collecting a lot of data, testing the vehicles and things like that. So as time is limited to 45 minutes, about 1 hour, so we would share you some of the insights that it excites you to learn, because there is a lot of requirements in the industry for someone to become powertrain engineer. All right. So if you want to become a powertrain engineer, so this is the testing is actually one of the part of whole development process, right? And today we would be going to learn about all these topics and overview of testing, some standards, procedures for testing, and what kind of data we collect and how do we compare the simulation to real-time test data and stuff like that. Cool. So with that, I invite and hand over the session to Srinidhi. Over to you.
Thank you, sir. Good evening to Anana. So today's session is on electric vehicle testing and validation. Just let me go. Yes. So today we'll be looking into foundation to electric vehicle testing and also on the validation part. So before we look upon how do we do the electric vehicle testing or any IC vehicle testings, what is the major or what are the needs that why do we do a vehicle testing? So when we look upon that, first and most important comes on the prototype evaluation. So before we start building a vehicle or we have a certain project, so before it enters the public market, we would have a prototype iterations, maybe 1 or 2, 3, and depends on the particular project. So to evaluate till what extent or what is the current value of that prototype, has it performed according to your goals or outcomes which you had set before you built the prototype or while you build the prototype. So to evaluate this process, we go through vehicle testing, where you get to know what is the current status or after the state, what is the status after testing, what are the goals had set before, and what were the results which has been achieved. Then we also look on test and analyze prototypes. As I was mentioning earlier, we need to analyze our prototypes in each stage, each optimization. What value does it give after the each optimization or each every different steps you attend in the prototype stage. Then as also on the optimization of the vehicle, another most important in vehicle testing is to have a in-depth knowledge on real world performance. So You might have heard people testing vehicles has been testing in ARI or some test under standard controls, standard environmental controls, where there's a dynamo, uh, where a complete testing area has been controlled, which is not, which is I would say, which is different from your real world scenarios. So while you do a vehicle testing, you would come up with all the real world scenarios, maybe traffic conditions, weather conditions, any sudden acceleration, deceleration, any hurdles in between. We would also get the realistic energy consumption parameters, like via simulation or via under a controlled environment. The range which you get, the total energy consumed, is completely different to realistic scenarios. That might not be true when you go in a complete high traffic, or complete that might not be true when you go on cruising in a highway. So it completely differs. To understand in depth each various number of tests, various number of scenarios, we go through vehicle testing, where we will gain a complete results or in-depth knowledge on what was the realistic values. Then one more important thing is components efficiency. We might have considered maybe in simulations or MBD that a constant efficiencies, right? Each component performs differently with various scenarios. For example, your motor controller would perform at 85% efficiency at certain RPM, right? But when you go in the vehicle goes in public, in different roads and different scenarios, the efficiency will differ. To get in-depth knowledge of what is the efficiency at those certain moments, we need to go through testing. So another important role of when we talk about vehicle testing is components optimization. So as I said, maybe we go with certain kilowatt hour battery pack, certain kilowatts motor, and certain so these particular components might not be suitable at the end of your prototype evaluation. You need to optimize it for next for your final product. So to do that, we go for the vehicle testing. As I mentioned, we are also to gain the real world range. So you might have seen in all the any X and Y Z electric vehicle manufacturers stating that so and so range with a star mark, which the star mark indicates that it is according to standard conditions, right? So to get the real world range, we do vehicle testing. And finally, validation. Validation in the sense maybe the modules which you say powertrain modules are what are the values you're getting in simulation? Is it accurate with real time? If not, what is the accuracy? And again, if not, where all does it have a drawback? Where all the simulation model has to be optimized to get a more accurate value? Also to validate each and every components which has been selected by the technical team. So they would have selected a particular component based on some so and so specification. Does it withstand even after testing, as as it was discussed on paper or on theory or on simulation? So right now, what you're seeing on your screens are the electric vehicle testing centers in India currently: NATREP, ARI, Global Automotive Research Center, ICAT. So few are directly from central government association, few are as a private organization, where if you are a OEM, I mean, if you come up with a product tomorrow, and if you need to get tested, you can just approach ICAT or Global Automotive Research Center and get their certification, which are valid for your RTO registration or for your manufacturing level. So as I was mentioning about the vehicle testing standards which are followed, these are all controlled environment, where you can see on the left hand side there's a dynamometer. For your resistive force, there is a simulation of the resistive forces are simulated via fan, and all the loads sometimes are again simulated via the dynamometer, certain loads which are not completely realistic to what you drive in day-to-day life, right? These standards give you a different results when you compare to real. And again, when you look at the tracks which you're saying for testing tracks, you can see some test tracks for the slalom. You can see the test tracks for the braking distance, stopping distance, gradability. There are tracks with certain predefined grades, 7 degree, 13 degree, and what was the acceleration on the gravel road, tar road, mud road, sand, and what was the braking on all different kinds of roads. So in this picture completely depicts that these are all predefined area. Nothing, I mean, it's completely different in day-to-day scenario, right? So till now we understood why testing is required, how things are done. But before we go into real world testing, what are the equipments required? Basically, you need a test vehicle. This test vehicle will be your any prototype versions, right, before it enters to the market. Then a custom battery pack. Why custom battery pack? You can't go with just a predefined or on-shelf ready products of battery pack, because they are still in optimization stage. So today you might be requiring 4 kilowatt hour battery pack. After your test, you might feel that you require more a 0.5 kilowatt hour battery, right? So go with a custom battery pack and with a configurable battery management system. So what is the use of smart BMS here is that you can monitor completely what was the current discharge value at each second when you were driving. For example, this is point A, point B. If you're going from point A to point B at certain speeds, you went from 0, 40, 30, example. So at certain speed, how much the current was drawn from battery based on the load which was taken by a motor, right? So to log this data to understand how the battery is performing, you go for the smart BMS. Then and this via smart BMS, you can change the parameters. For example, if you have limited 30 amps as a maximum discharge current, but you might observe in your testing that for some particular grade areas or for some particular acceleration values, you are not able to achieve due to this constraint, and you want to optimize the discharge current level. You want to go up, or you need to decrease it or increase it. All these things can be done if you have a smart BMS. Then is to support this smart BMS, you'll also have a software interface along with it. Then a motor controller. Again, the motor controller will be configurable, because you might feel that you need more amount of current has to be down to attain certain torque or certain speed. So this can be done via a configurable motor controller. Then also a supporting software for that. You would require a GPS tracker to locate all the location where you are going, one part. And the main other objective is to have a GPS speed. So you require a GPS speed tracker. Then road profile data acquisition system. So what do you mean by this road profile data acquisition system is, for example, in any of the roads, as I was mentioning about gradability. So you will have a road profile data acquisition system placed in your vehicle with a reference at 0. For example, you can take as this floorboard, and we'll have the device here, and which will be set as a reference at a flat ground. So from that flat ground, you would able to collect the data around 200 hertz to up to 200 hertz, starting from 1 hertz. For each second, what was the grade angle with respect to the vehicle. So your vehicle is, I'll just show you. climbing a hill or a great angle. So this is your vehicle. So with respect to your vehicle body, where the device has been placed, what was the angle with respect to the road profile? So this you can, completely get by using a road profile detection system and a laptop or any other medium to collect all the data. You will have numerous values from each data acquisition system. So you need a common space to collect all that. Then a vehicle charger, because vehicle charger also plays a vital role in EV, because even those has to be tested whether your charger is able to perform similar way even after 10,000, let us take a number of 1,000 cycles. So you are going to keep charging for 1,000 time, whether the charging time was same, whether the efficiency was same, similar to before. Then safety gears, at most important at the end. Okay, so now as I was talking about vehicle testing, what all the equipments are required. What is the purpose of vehicle testing? Is as I've explained. So how do we do that? We create a drive cycle development. So a complete drive cycle is developed from point A to point B, where all the data will be connected. As I mentioned here, BMS discharge current, vehicle speed, all these data which are important will be collected from point A to point B. So where all this speed versus time which have been collected for each, what is the speed according to each second, that is called the drive cycle. And there's a process for all the drive cycle development. Here I am representing to you to some of the real-time drive cycles which are generated standardly also, or these are the drive cycle which are generated decibels for our vehicle testing purpose. So first one is the real-time urban drive cycle, where this would stress more on completely city or urban life cycle with various traffic condition, low, medium, low, moderate, and high traffic. Then some next test would be like the highway drive cycle, where you would be finding what is the cruising speed of your vehicle while you're cruising, how much amount of current has been drawn from your battery pack. Then some tests are conducted in suburban, where it concerns some certain of city and some certain of suburban area, where it's kind of a low traffic area. Then a major test, acceleration test, so which would define your vehicle's performance. This test is done at various SOC. Why do we do at various SOC? When you compare it with the IC engine, if you're doing an acceleration test, let's take an example 0 to 40 or 0 to 60, it doesn't matter much in terms of how much amount of fuel is left, except the weight of the fuel. If you just neglect that part, even if you have 1 liter of fuel, even if you have 500 ml of fuel, it will perform at its peak, right? The engine will perform at its peak. But that doesn't happen when you talk about electric vehicles. So going 0 to 40 in 5 seconds at 100% SOC, a vehicle won't be able to perform same at 50% SOC, because there are some certain cells which they won't be able to give a complete performance at even when the cells are being discharged. I mean, they are at different SOC levels, a lesser SOC when you compare it to the full charge. Then we have gradability test. As I mentioned, we go to a predefined area, or you go to a complete steep or complete hill station. Then something called as peak and hold test, which is again a replicate of a highway, I would say. By you attain your peak speed of the vehicle, or maybe a high speeds of your vehicle, then you try to hold it. That would replicate something like a cruising speed. You go from 0 to 100, and you in highway you just keep on cruising at 100 or 120, right? Then range estimation. What was the range you attained from 100% SOC to 80% SOC. Then again 100% SOC to 60% SOC. So with a lot of variation, we conduct a range estimation to know that how the battery pack perform with respect to different SOC. When you have 80%, what are the performance? At 60%, what is the performance? So in-depth study has been done for the range. And also a different drive cycles are collected for the range. What is the range when you go for city? What is the range when you go to a highway? The things are not similar to IC engine. You might have heard most of the IC engines, which are not overstressed, right? They perform very well in high cities, right? They give 45. I'm just giving an example, 45 kmpl and all. But that when you go for highway, some vehicles perform vice versa. They give a lesser value. So for electric vehicle, it completely depends on speed, and it is not completely similar to IC. So the range difference from different types of drive cycles, different drivers or riders, different riding situations. Then also we do the battery test, charge test. As I mentioned, we do various number of tests on 0 to 50% charge. How was the charger performing? How much amount of charger was what do I say? Drawing the current to charge the battery pack. How was the charger? How was the battery packs, or how were the cells behaving while charging? So all these parameters are in-depthly seen during this test. So from now, I'll be giving you some examples on the vehicle which we have tested. So here are the few results for the Hero Flash, which is a low-speed vehicle. This vehicle was tested at Decibels. So the one on you see on the screens are the acceleration test. So I was mentioning there's a lot of difference between IC and EV vehicles acceleration test, right? In front of you, I'm just presenting you the 100% SOC acceleration test and 50% SOC. The vehicle is same, all the test conditions are same, except the SOC only. Driver's weight, a driver, test track, temperature, all other testing conditions were same, only the SOC was different. So you could see that 0 to 40 kmph was reached in 14 seconds, whereas at 50% SOC, it took around 20 seconds to reach. So there's around 6 seconds of difference, right? So it really matters to perform your vehicle at all scenarios and understand how the vehicle performs. And I have mentioned here 36 kmph as a GPS speed and 40 kmph of auto. There is a difference of 4 km/h. Why is it? There is a certain government rule which are followed for the electric vehicles, or also some of the IC vehicles, that there should be a 4 km/h difference in the odo compared to the actual speed, just as a safety reasons. So these were the part of the data collected from GPS tracker. That's the speed versus time, right? This is from the battery pack. As I was saying, we have a configurable BMS. BMS would give us the current status, how much amount of current I was drawing during my acceleration test. So on the left hand side are the realistic data from BMS. On the right hand side is the model data. Model here I state that as a powertrain MBD design, so model based design. So where a complete powertrain model was done. We had fed the this particular drive cycle to the model, and these was the results obtained. So you could see that in realistic, as soon as I gave a complete throttle, it attained a peak current of 30 amps, right? And it tried to maintain that peak current. After, unless it started to be complete movement, then only the discharge current kept on decreasing. But in model, that was not the scenario. Model was drawing the current according to only speed, no load there was a constant load. That was only the driver's load. But when you see in the realistic, the motor load will depends differently on which road profile you are, and how much amount of current you're trying to draw. So the similarities were not much seen when we compare with the model data. Then we were able to understand what were the drawbacks that model had, what has to be optimized. So there's the testing scenario for the 50% SOC. Again, you can see there is a sudden current drawn from up to 30 amps, and you could see that at 100% SOC, the time taken to reach the peak current is very less than around 1 second, or right? But that was not the scenario for the 50% SOC. To reach the peak, to reach the peak, it took a long time due to its inability to perform, right? And this is the BMS model. So this is another example of gradability test where I have predefined the distance, top speed, which was attained, what was the start SOC, what was the average grade, and time taken to reach. So here you could see the top speed was around 11 kmph and distance is 18 meter. Again, when you talk about gradability test, according to ARI standards, which is basically AIS 003, which states that the distance for your gradability test has to be 15 meters plus wheelbase of your vehicle. So here it is 3 meters plus 15. So that's your complete distance. That is how ARI test. Then you could see the videos. So you could see it's pulling very slow due to the SOC, lower SOC, remaining SOC, sorry. So again, this is the BMS data for the gradability test. This is the battery current module from the BMS. So there are few improvements after we found out what were the drawbacks in the model to match up with the realistic approach. So now when we go for the bigger test, that's on city drive cycle, highway drive cycle. This is an example of city drive cycle. So the drive cycle itself depicts you what is the scenario at city, right? You have a lot of acceleration, you have a lot of deceleration. So this frequency keep on repeating. There's something called as a stop time here. You have a lot of number of stops here. This is number of stop 2, 3, 4. So you have number of stops here. You have stop time. The stop time might depict you a traffic situation. For example, you might be in a complete 120 seconds traffic, 60 seconds traffic, whatever those scenarios are depicted here. Maybe someone have was like you came across some hurdles, maybe some vehicle came, some cattle, anything you can take example. So this depicts the complete city drive cycle where you don't have much of a top speed in city due to the high traffic condition. Where this test was taken for 2,300 seconds, distance 15 kilometer, average speed was 22.66 kmph. What was the start SOC? What was the end SOC? So how did the vehicle perform from 70% SOC to end up to 43% SOC? Was studied in city drive. So you can see here, this is the BMS data. You can see there's a lot of variations in the BMS. It's discharging rapidly, right? You could see it going from 0 to 30, again dropping back. So where we would be able to study that whether the battery pack is able to discharge at such faster rates. This is the battery current model data, which is almost similar. As I said, after we keep on optimizing your model, you could get some realistic serious results. This is regarding the highway drive cycle, where you could see, as I said, this is a low speed vehicle. So I was only able to maintain a top speed of 40 and I was able to cruise between 30 and 40. There is the BMS data, which I achieved for the same. And this is the battery model data. So now we would see that what all analysis can be done from all the vehicle testing, right? First thing is everything comes at a cost here. Start from your prototype building, testing equipment, test lab setup. Everything requires a cost, right? And there's a lot of uncertainties. So when you're going, there's a weather condition change. There might start a sudden rain. Road conditions might be very bad. Uh, Unfortunately, there can be a scenarios of accidents too, or a connection breaks due to road condition. There's some connection break. These data acquisition systems are a bit of delicate, I would say, because and they have accuracy only unless they are connected properly. Once if there's a bit connection problem, then you won't be having thousands of data, right? For maybe 100 10 kilometers, 20 kilometers, whatever test has been done, those all data would be gone. There are scenarios where vehicle might break down while testing. Then when you talk about data collection, there's a lot of GPS error. GPS signal works in the open space, right, properly. So if there's a cloud, you won't be able to get the right speed at that second. It will be keep on varying. Then there can be some data files error, uh, and there's a big task after you collect the data, that's called data sorting. You would have collected 10,000 data, out of which only 1,000 data would be valid for your simulation team or for your testing and validation. So again, sitting and sorting all the 10,000 data is a bigger task. So here, I was just stressing about the what are the cones, I would say. Yes, vehicle testing is very important. In practical, it has to be done. But before that, how can model-based design help you to build your first proto only as a very accurate or very nearby to your final product? Or I would say, how do model-based design help you to cut the iterations of building more number of protos in practical, right? So in that way, if you see where all model base helps you, it saves cost completely. You sitting with a complete a setup at a certain place, you can build the complete powertrain in just your laptop or any working models, right? It completely saves the cost of prototype testing equipments until at least the final optimization vehicle model is set up. It also avoid all the uncertainties such as weather condition, road conditions, accidents, all right. Then data collection error and large amount of data sorting can be easily done via MBD softwares. There are just codes where you write and all the data can be sorted within a no time. There are you can the major important benefit is that you can optimize the model n number of times before you build the final product. If you would do this without MBD directly going to the building the vehicle prototype and testing it each and every iteration, it will cost you a large amount, right? So before you decide for the final specs, maybe component sizing and all. For example, just imagine you just go do some mathematic works based on a paper and size a motor or a battery, whether without knowing how the battery or motor would perform for various scenarios, and you just built it, and then you understand that this was not the suitable for your product. That a waste of complete energy, time, and money, right? So those all can be cut shorted with the help of embedded design. So how can we do, what all component sizing can be done in MBD is like you can calculate the resistive forces such as rolling resistance, gradability, aerodynamic force, acceleration force, wheel torque, wheel speed can be calculated, motor torque, motor speed. You can play with gear ratios n number of times to come up with a accurate or right gear ratio which would be able to perform at high efficiency of your motor for all the torques and speed uh, motor operating points. Then useful power, nominal power, peak power. what are the operating points, motor current, how was the motor current varying along with the load and drive cycles voltage. And you can talk about battery packs. How was the SOC going down along with your drive cycle? How was the battery pack discharging at what C rates? Then cell capacity, cell voltage. Each things can be sized via MBD. So I'm just giving an overview. How does a MBD looks, which concerns all the subsystem. When you talk about powertrain subsystems like chassis, transmission, motor, battery, and the end results, where you would be getting the almost at least the range of your component size, right? The chassis will include all the resistive forces, transmission will include the gearbox. Again, whether you're using a reduction gear, what should be the gear ratio value? Then motor, battery. And in advanced MBD, you can also calculate the amount of regenerating which has been produced from a vehicle, right? So these are the few results which you obtain from the MBD. You can see this that particular result for the gradual acceleration and deceleration test. You could see what was the acceleration force, aerodynamic force, what is the mill torque and motor torque. You could see for the motor torque, there's a negative part here, right? Even from 0 below. So these torques will only play the vital role when you talk about the regenerative part. So these torques will add upon giving a regenerative power to charge your battery pack. So you could observe the motor torque and wheel torque are same here. That is due to the vehicle which we used was a hub motor, right? So there was no transmission in between. This is the wheel speed and the motor speed, battery power, motor power, battery discharge C rate. At what C rate the battery was discharging, what was the SOC drop, what was the energy consumption per kilometer. So like this, various n number of parameters can be completely observed and attained to give a right sizing for your prototype or for your vehicle. So by the end of the simulation, you will be getting the figures for what should be the wheel torque, what should be the nominal torque, peak torque, wheel speed, motor speed, then nominal power, peak power, motor current, motor voltage. So based on this motor current and voltage, you can decide what should be the motor. Then again, based on your load, you can decide what should be your battery pack. Then also you can simulate for what should be the range. So again, as a based on what range you want to achieve based on simulations, you can try to build your battery pack size, right? So this is an example of how do you do a component sizing for a motor after you get certain results from your simulation. When you collect a characteristic graph from the X and YZ manufacturer, where you would give you motor torque versus motor speed versus motor power or motor efficiency, where after simulation is done, you would be getting a motor operating points, as I mentioned it at the starting. So you can just cross check with the OEMs, I mean the motor manufacturer data sheet, and get a complete understanding whether this motor will work or not. So this can be done before you fix the module or fix the motor or the component to your vehicle. Just by checking at the data sheets, we can come up with a certain, I would say 85 to 90% of decisions can be taken based on your accurate simulations model. So yes, there are some limitations, I would say, for even for the MBT, because it's difficult for the MBT in MBT to imitate all driving behaviors. If you take 10 types of riders, each person will have his own driving behavior that might again change on the situation or environmental condition, all the behavior changes, right? Then we don't know a component's efficiency in a dynamic approach. That's what I was stating. When you do the vehicle testing, you will be able to know what is that dynamic efficiency of the components. That is a bit of a lagging in MBD side. Then when you talk about resistive forces, yes, while front resistive forces are calculated, it's a bit difficult to calculate what are the crosswind forces. Then it's again a bit of difficulties to imitate the different road conditions. The CRR might change with all type of road conditions, right? That is again a bit difficult for our, I would say, limitation in MBD. Performance of vehicle after the drop in battery capacity due to usage. So you saw the acceleration test for the 100% SSC and 50% SSC was different in realistic, but when you compare it to a model, the changes were not shown, right? Then it's again a bit of difficult to calculate the battery life cycle. What is the complete battery? Whether it will come up to 2000 life cycles, whether it will come to 5000 life cycles. So it all depends. So finally, what you could see is the factors which are affecting the range, right? So you might have heard when you compare with the IC engine range affects on just the speed and how you ride or the maybe CC. Lot of factors plays a vital role when you're deciding about the range of your vehicle in electric vehicle. Start from your components, efficiency, transmission, motor, inverter, battery, power electronics. I'm talking about a bit of I wouldn't say atomic level, sub components, small components which are present in a EV. All the electronic components have their own efficiency. They even produce some amount of heat. That's again energy loss. Then HVAC system, when you come to bigger vehicles that are for four-wheeler, where for the HVAC stands for all your AC, heating and cooling, auxiliary devices, your instrumental clusters, audio device, charging depends, the way you charge, fast charge, slow charge, environmental condition, road type condition, traffic condition, driving behavior, driving condition. So n number of parameters play a vital role when you talk about just a range of your vehicle, right, in EV. So thank you all. So if you have any doubts, you can just put it on chat box or Surya sir, are you available?
Hi Srinidhi, by the way. Yeah, great. Thanks a lot for the good session. For technicals in place. Yes, floor is open for questions to everyone. Also, let us unmute, give an option to unmute. Yes, as you have an option, we can unmute as well. There we have given you an option like that. So if you have any questions, so please do put your queries in the chat box.
Hi.
Or you could also unmute and speak, please.
Hello.
Hello. Hi, John.
Hi. I just have two questions here. So in the slide for EV testing equipments, so can you just explain once more why we are using the GPS tracker and also the road profile data acquisition system?
Sure. Yeah. So when you talk about GPS tracker, why? Because to get an complete vehicle speed accuracy, when you compare with the IC engines, you have a OBD scanner where you attain the vehicle speed, right? Sometimes a GPS tracker will be able to give you the with higher frequency, maybe for milliseconds, what was the speed. This would help you in component designing for your acceleration test, or maybe certain a bit of difficult situations. Then regarding road profile, when you talk about EVs performance or range, each forces plays a vital role. So even the vehicle going, it's very what I would say a basic requirement to know whether your X and Y vehicle will be able to climb at least any hilly region or any certain grade which you come across daily. So to know that, we will be using a road profile data acquisition system to know what is the grade with respect to your vehicle and the road. What is the grade, right? So this is how it plays the vital role.
Uh, so the road profile data acquisition system. So how is it implemented on the vehicle? Is it fitted onto the wheels of the
Yeah,
vehicle, or what is the procedure to measure that
that is
road
what I
profile?
was saying. These data acquisition system are placed on horizontal surface, completely flat. So, for example, our test equipment, we have a road profile data acquisition system fitted on the floorboard. This board, could you see this? 1 second. Yeah. So here, then you calibrate it and you set the reference. You set the reference that this vehicle right now is in 0 degree. From that moment, if when you move your vehicle, whether it's going uphill or downhill, all the y-axis will be recorded, and that
Okay, understood. Yeah.
yeah, and this data can also be given as an input to your MBD design, right, to get more accuracy.
Yeah, correct.
Yeah.
Right.
So we'll just another doubt attached to that grade. I think it was covered in yesterday's session, but still I'm asking now because so when we are having negative gradient like downhill section, so those cases won't be considered while powertrain sizing, right? We will be considering the extreme side of that gradient.
Right. That's what I said when while testing the discharge current was different, right? When you compare it with BMS data from the module or from the powertrain module. So again, here, as you said, when your deceleration are going downhill, if your vehicle has a regenerative property, so we can able to collect the data such as what was the amount of regenerative what was the percentage of regenerative which was achieved at that certain downgrade?
Okay, understood. Thank you.
Sure.
Right. Good to interact with you, John. So yes. So as Srini was briefing you out, so if in case you have a negative gradient, typically what happens, you don't need to actually provide a lot of power input to the motor. So if you want to study those scenarios um, where it's just that you would consume lesser energy than your a typical situation without negative grade as an option. You can simulate, but it's just that if you would like to go over to that achieving
Sir,
3% accuracy, yeah, so you would possibly take that edge to consider even that parameter as a case to
sir,
implement in the model.
hello, sir.
Yes.
Yeah, hello. So
Sir, is there any angular position sensor to be needed to measure the gradient angle of the vehicle, which data is related to the control of your vehicle?
yeah, we use inclimeter.
Okay, sir. Thank you.
And someone has asked, are these MBD designs done on MATLAB? Yeah, you have various softwares. It can be done MATLAB, Scilab, even Altair as active, where you can design your MBDs.
Yeah.
Any other questions?
No, sir.
All right.
That's good.
So great. Because if anybody have any questions, so floor is open for discussions. So feel free to ask questions. So before we wind up the session with some more details in place. How can I get those drive cycles data from experimental purpose? Right. So as far as Bajreshwar, so the drive cycle is basically velocity with respect to time. So you need a sensor that captures velocity, right? So you could get velocity from various sources. You could get a velocity by putting a sensor to the wheel, or you could get a velocity from motor controller. You can get a velocity from GPS. You can get a velocity from any other source that you can potentially find as a velocity. So, and then plot it, use that data, collect the data with respect to time. So when you do that, so you would be able to get your velocity profile with respect to time. So you have one of your parameter that is majorly a contributing factor. So then you can derive your acceleration also from the velocity with respect to time as well. That's how you get your drive cycle. If you would like to go ahead with the available drive cycle, you have UDS, you have NEDC, IEDC, any regulatory drive cycles that are used for homologation purposes. Yeah, you can go ahead and download from the internet. There are many sources where you can get. But if you want to generate your own drive cycles, you have to basically use some app or use some sensor data acquisition system. That is just to do that. So again, velocity and time is the parameter. Then again, you have a theta that is basically a road profile, right? So it's basically an angle. It can be called as a grade or any inclination of the road. It may be negative inclination or a positive inclination. So you could use sensors such as 6-axis gyroscope. They can be mounted on a specific place. Again, it's not just something easy. You get a lot of error data, you get a lot of noise data, and you get completely bonkers in solving it if you don't know how to solve it. So there are a lot of things in place, but yeah, it is also used for the purpose of estimating the load on the motor. And apart from these things, that's pretty much sufficient for you because you have mass and rest of all the parameters like tire pressure, CRR, which is rolling resistance and stuff like that. So all are available constants for you. All right. So perfect. So in the meantime, I think everybody's just talking, chit-chatting. So you guys have an option to fill the Google form quickly. So yes, there is a link here. So it's mandatory for all of you. So just kindly take a minute to fill the Google form that is mentioned in the chat box. Yeah. Okay. There is another question. How can we calculate the amount of heat released from each cell of the battery pack? Fantastic. So, hey, it's just not a one-line answer that you could give because heat is generated because of various different reasons, and just can give you where you can get started. It happens because of reactions that are happening inside a cell. All right. So reactions are directly proportional to discharge or a charge. So both of them are directly proportional to current, right? So you're getting, first of all, having a cell, you know what is the matters that are impacting. One is charging and discharging. So you can basically correlate that to current. So now you know current, and then you need to perform some tests and collect the data, maybe like some parameters like specific heat of components and stuff like that. You will be able to averagely identify the temperature rise in the cell. Again, temperature is not influenced only as a discharge current, it also has influence of atmospheric temperature as well. If your atmospheric temperature is about 45 degrees Celsius, obviously the cell will be higher than that temperature, even though without charging or discharging. If temperature is 45 and you're still charging the cell, then it could be definitely more than about 50, 55. Right? So there are influences, majorly atmospheric temperature and then the discharge current. If you're able to correlate and draw a curve for rise in temperature, so you would be able to correlate how we can actually calculate this stuff. Okay, so there is a query stating that you're not able to open the form. All right, so just give us a second. Okay, I just checked it, John. So I could do that. So yeah, kindly check it if you are able to. Check it now. Yeah, I have checked it, so I'm able to correct it. So you could also check it out. Okay. So any other questions from anyone? Right. So yes, guys, that's the link that we have sent it to you. You could just go there and how is the data acquired from test vehicle, from the BMS and motor controller? Kasim, so you need to have an option, first of all, that to collect the data from motor controller or a BMS. So first of all, yeah, choose the right equipment that gives you an option of logging, correct? So that's the whole funder. You need to talk to your vendor. If your vendor tells you that, okay, you can do the logging, you can do the logging. If they say, no, you cannot, then you cannot. So they will give you a software, they will give you an interface, they will give you a hardware. You can hook that up to controllers like motor controller or a BMS and then to a laptop. There would be some amount of devices in between. So if you can able to put all of that together, then you can actually acquire the data. Okay, so certificate link is not working. Okay. Let's just check it out. 1 second, everyone. Any other questions from how and where we can store regenerative energy? Right, so there is nowhere else except batteries you can store the regenerative energy. Okay, perfect. So I will just show across the details how you could take the certificate as well. Let me just share my screen. Okay, so anybody have questions, you can just put them in the chat box as well. We will look forward to help you. Great, so everybody have this link that is shared in the chat box, and I'm resharing that link again. All you have to do is just land on this page when you click on the link, all right? So what we have done is we have listed some courses. They can benefit you in upskilling on this link. So there is a coupon code our team will send you to actually take up any of these courses. Specifically, these two courses, which is on EV technology and thermal management and high voltage system, gives you a system level idea on what is an EV, what components are there, what systems are there, very much in depth about each and every component of EV. Because before you start something as simulation, as a design, you guys have to know very well about component system, subsystems, technology, and stuff like that, because you can actually make things maturely in decisions. So it's very important. Somebody just thinks that, okay, this available, I know in internet, these components are there. But what happens is that's how everybody thinks what is in the news is basically technology. So what is in the news is technology. So it's a little bit of a garbage. So we have done a lot of efforts in actually collecting very specific data with our expertise and extensive amount of research to kind of bring you an idea of systems and subsystems and stuff like that. So we have put across those two things in this course. So where you would be able to understand and appreciate technology of EV and intricacies, complexities, design challenges, future ahead of technology as well. Then we have course on quasi-static approach of powertrain modeling that is in continuation to the day 2 session, right? So these 2 sessions are continuation to the first 3 session that I have delivered for my topics. And this is in continuation to the day 2 session. That is where you have learned just using Excel how you can do it. But if you get a system, if you want to develop an EV, there is more than about 120 test cases. You can't just plug Excel and make it to work because it just impossible to manage your data. So you can actually model a EV in a very professional approach using powertrain modeling course, where you could actually build a model in MATLAB and Simulink purely, not using dumb side of the Simscape, right? So then coming to the master course, we have this course that is dedicated for people who would like to build their professional career in the EV. So if you're interested to make your professional career, we have a 100% placement guarantee master course. That means we sign an agreement with you that we will help you to get a placement. So that's a commitment from our side, but you need to also meet certain prerequisites to be a part of this course as well. And we take 5 people for a batch. So we have the batch starting by 27th June. We have opened up our enrollments. If you are interested to explore, and you should be a fresh graduate or you should be a working professional to take up this course, all right? Then you can actually take up this course. So this is a dedicated program. It's a 9 months course that can happen offline and online as well, which talks about complete development cycle as an EV product. It's like if you take up this course, you would gain an equivalent experience of 2 years to 2.5 years. So you get the amount of maturity to join any company, right? That's a confidence we also have so that we can help people getting placements. So currently we have trained people. Few people work in companies like Hero. We have few people working at Simple Energy, and we have various other people working in different startups as well in the EV sector. And we have also trained people who works at Ola, who works at different companies across the globe as well, like Toyota. We have Powertrain and various companies across the globe as well. So if you're interested to learn, and this is the course that will be a perfect fit for you, and if you are seriously trying to build your career, or if there is somebody who want to switch over your career from gasoline, diesel calibration to a electrification side of it, right? So that's the beauty of this course, which is can help you to build your career. There's a link which I might have shared you as well. It's called Master Course. You can take up this program if you're interested in it, and you can fill the book your counseling session option so that our team will be able to help you in getting that. Now let's get back to the certification thing. So what we are supposed to give you as a part of the course completion certificate. So it's very simple. Go here, certified bootcamp on electric vehicle powertrain, right? There is a button which shows us enroll for free. Yes, you need to click on this, and then first of all, sign into the account, all right? You can sign into the account. When you click on enroll for free, you would get inside a course because you would have already logged in, okay? So then you just need to complete the process that is inside the course, like step by step. If you do that properly, you will get the certificate automatically, all right? Just before you generate your certificate, ensure that your name is displayed correctly in your account, okay? When you click on sign in, you sign in to your account first. That's the important thing. Once you sign in, just check going to your account, my account details, all your name is correct, because sometimes you would have used like, John Cooper or, whatever it is as a nickname. So, but just check if everything is correct. Once everything is correct, then click on the enroll. Once you click on enroll, you will be able to generate your certificate. All right. So just follow the instructions given to you inside the course. So I'm sure you would be able to follow through the instructions on this. This link is valid only for 1 hour and even a little less than that. So if you want to generate certificate, please generate it quickly right now, because we don't want to give a certificate to somebody who don't participate in the course, right? And this should be value for them as well. Okay, Mr. Sanju Gaur, follow the instructions as given. You will be able to generate certificates, because if you see some comments below, there are students like Sahul who are able to generate a certificate, right? So you can generate the certificate because other 3,000 people in the past courses have generated certificates in the same way, right? So just if you hit on the enroll for free, then you just follow the instructions in the course that is given to you. Once you complete all the instructions given in the course, you can automatically get the certificate. Right, so any questions from anyone? Okay, so good. If you have no questions, I think it's good for everyone at this moment. Right, Qasim. So you will receive an email from our administrative team so that how you can get the coupon code as well. All right. Let me just check with them if they have created any coupon code to share it across to the participants. But though there will be an email that is coming to you by tomorrow morning that will have an optional coupon code. You can basically use that to enroll in the course as well. All right. Okay, so any other questions from anyone? Okay. All right, so any questions from anyone? Okay, so good. We don't see much questions at this stage. By the way, thanks a lot, everyone, for being a part of this wonderful course. And because of you, obviously, we find the interest to share our knowledge. And it finds it really great to have you all here. And thanks a lot again, everyone, for making the session. And thanks a lot, Srinidhi, for sharing your experience and also wisdom for everyone. And thanks a lot, everybody else at Decibels, Vinayak and Krishna, and everybody who have been coordinating to support in hosting this course. Again, at last, definitely thanks a lot for you to show the interest in attending this course and making it a great, successful event. Okay, thanks a lot, everyone. Again, good day to all of you. Good night to everyone. If any questions are there, you will be able to attend future sessions as well. We have upcoming future sessions in the, I think next week itself, we have a repetition of the session. So if